When you stretch a spring, most of the time it snaps right back. Other times, it just gives up and bends out of shape. This simple observation sparked a scientific obsession in Robert Hooke, who focused his research on springs, force, and how materials stretch. In his search to understand how materials behave under stress, he uncovered a law that still powers engineering and robotics today: Hooke's law. Before we define Hooke's law, it's important to understand elasticity. Although we'll focus on springs in this video, the law applies to all elastic materials. An elastic material is one that changes shape when you apply a force, but then returns to its original shape once the force is removed. Think of a rubber band, sponge, or even your skin to some extent. These materials are elastic because they recover after being stretched. That's the foundation of what we're about to explore. Hooke's law makes much more sense when you understand what makes materials bounce back and what makes them break. That's where elasticity and elastic limit come in. When you stretch an elastic material, like a spring, it usually returns to its original shape after you remove the force. That ability to go back to its original form is what we call elasticity. But what happens if you stretch it too much? At some point, the material won't return. It stays bent or stretched. That's because every elastic material has a limit to how much force it can take and still go back to its original shape. If you go past that limit, the material changes permanently. This limit is called the elastic limit, the highest force a material can handle and still bounce back. Go above it, and the material won't recover. For example, if you apply 10 newtons of force to a spring and it returns to normal, 10N is within the elastic limit. But if you apply 10.1 newtons and it no longer returns, then 10N is the elastic limit of that spring. It's the point just before permanent deformation begins. So far, we've seen that elastic materials can stretch and return to shape unless the force goes beyond a certain limit. But what happens when the force stays within that limit? This is where Hooke's law comes in. Robert Hooke discovered that the amount a spring stretches is directly related to the force applied. In simple terms, if you double the force, you double the stretch, as long as the spring hasn't reached its elastic limit. This predictable relationship is called Hooke's law, and it applies to springs and many other elastic materials. Hooke's law states that for a helical spring or other elastic material, the extension is directly proportional to the applied force, provided the limit of elasticity is not exceeded. Here, extension simply means how much the spring length increases when stretched. It's the difference between its stretched length and its original unstretched length. So how do we express Hooke's law mathematically? It's written like this: F equals Ke, where F is the force applied to the spring, measured in newtons. E is the extension of the spring, measured in centimeters or meters. K is the spring constant, which depends on how stiff the spring is. This equation tells us that force and extension are directly proportional, as long as the spring stays within its elastic limit. Understanding the spring constant. Now let's talk about that constant, K. It's a number that tells us how tough a spring is to stretch. We call it the spring constant or stiffness. If K is large, the spring is stiff and doesn't stretch much. You need more force to extend it. If K is small, the spring is soft and stretches more easily. You need less force. So, a spring with a small extension but a large spring constant is hard to stretch. One with a large extension and a small constant is easier to stretch. Now that we understand Hooke's law and the spring constant, we're ready to apply it. In the next video, we'll learn how to calibrate springs, explore series and parallel setups, and solve real-world problems using this law. See you there.